Reactor physics. Hello everyone, my name is Rafael. I am an electrical engineer, and in this video I'd like to speak with you about how to control a nuclear reactor. The fission process. By definition, fission is the splitting of a large nucleus into two or more nuclei. In this case, the large nucleus is the nucleus of uranium. Fission is triggered by the absorption of a slow-moving neutron. Nevertheless, the fission process produces fast-moving neutrons, and they have a low probability of causing fission again. To increase the probability of these fast-moving neutrons to cause fission again, they need to be deaccelerated. And this process is done by a moderator. Moderators deaccelerate neutrons. In pressurized water reactors, the moderator is common water. Now let's talk about neutron multiplication. A generation is the average time between fissions. Within a generation, many things can happen to a neutron. It can cause fission. It can leak out of the reactor. It can be absorbed by a poison. Any material inserted within the reactor that will absorb neutrons but will not undergo fission is called a poison. Now let's talk about the effective neutron multiplication factor. K effective is equal to the division between the number of neutrons in the present generation by the number of neutrons in the previous generation. Let's consider the effective neutron multiplication factor, K effective. If K effective is equal to 1, neutron multiplication is constant and the reactor is said to be critical. If K effective is less than 1, neutron population is decreasing and the reactor is said to be subcritical. If K effective is greater than 1, neutron population is increasing and the reactor is said to be supercritical. Since power is related to neutron population, when the reactor is critical, power is constant. Now let's consider how to control K effective. K effective can be controlled using control rods or source neutrons. Control rods have neutron poison materials that will absorb neutrons, such as boron, xenon, and samarium. Source neutrons come from material put in the core to give instruments a reliable background signal during startup. If the reactor is subcritical, K effective less than 1, and if there is no source of neutrons, neutron population would always be decreasing. Now let's see reactivity. Reactivity is a measure of the deviation from criticality. Its unit is ppm, or percentage millirho, and ρ is related to K effective by this formula. Let's see a question from a civil service exam for nuclear engineers. I'm going to read the question. A reactor is critical with banks of control rods partially inserted. If, when removing some banks of control rods, the multiplication factor becomes 1.055, the reactivity entered in ppm is approximately, what we need to do is to use the value of K effective. It is going to be 1.055 minus 1 divided by 1.055, which is 0.0521. Or in PCM, Rho is equal to 5.21 PCM. Okay, my friends, this was the video that I wanted to make. I hope you guys enjoyed it. I am a teacher. If you want to book a lesson with me, contact me using my WhatsApp number. Goodbye!